Hello everyone. In this video I will do an example for fundamental counting principle. Let's see what is the question. Question says let S, the set S, be a set of integer numbers 1, 2, 3, 4, 5. Part A asks how many subsets S have. Part B, how many subsets of S contain 2 but not 4. And part C says how many subsets of S contain at least one odd number and exactly one even number. Let's see how we can solve this. Well, part A, we had a formula for the number of subsets of a set with n elements. So if a set has n element, the number of subsets for that set is 2 to the power n. Here, in this case, it's 2 to the power 5. But how we find it? So to form each subset, what you do, you ask yourself if you're including this element, 1, is it included or not? B, is it included or not? 2, 3, is it included or not? So for each element, you have 2 options. And since we have 5 options here, for 1, 2, 3, 4, 5, these are elements. For first one, I have 2 options. I have second, for the second element 2, we have we can either include in the subset or not. So it has 2 options. For the 3, we can include or not. For 4, include or not, include or not. You multiply these by using fundamental counting principle, you get 2 to the power 5 that we have. How many subsets? Why did I use this? I did this again, although I knew the formula. The reason you'll see in the part B. So in how many subsets of S? We have 2, but not 3. So again, we have all these elements, element 2, 3, 4, 5. And when you're looking for the number of subsets which contain 2 but not 4, means that we already know what happens to 2. We don't have options. It is included. It contains 2. So I only have one option for 2. And for 4, also I have one option. It's not going to be there. There is no other option. So there's only one option there. How about the rest? Well, for 1, I can include or not. So there's 2 options there. For 3, I can include 3 in the subset or not. There is another 2. For 5, I can include 2 or not. So then, by fundamental principle, counting principle, you multiply these two. 2 times 1, 2 times 2, 2 is 2 to the power 3, which is 8. Part C is a little bit more complicated. It says that how many subsets of S contain at least one odd number and exactly one even number. Let's see, what does at least one odd number mean? It means that it has either one odd number, 2 odd numbers, or exactly 3 odd numbers. Yes. So here I have 1 odd, 2 odd, or 3 odd. And this is exactly 1 odd, 2 odd, and 3 odd. And it contains exactly 1 even. Let's see what would happen here. So I have exactly 1 odd. How many odds we have here? 1, 3, 5. So you choose one of these 3 and include it in the set. And then for the next, which is even, then choose one of those 2 subsets, 2 even numbers, 2 or 4, and include it in the subset. Yes. So for this one, I can choose any of these three, 1, 3, 4, 5. So I choose one of these. Then I'm not done. What about the odds? What about the evens? I have to choose exactly one of these two. So I choose 2, choose 1. That's the number of sets which has exactly one odd and exactly one even. Which, as you can see, 3 choose 1 is 3, and 2 choose 1 is 2. So I have 6 cases for this one. How about 2 odds? So in this case, I choose 2 of 3 odds, and then I choose exactly one of the even ones. So you multiply 3 choose 2 is again 3 times 2 choose 1 is 2, it's another 6 here. How about 3 odds and exactly one even? So you choose all 3's and then multiply to 2 choose 1, which is the number of ways you can choose one of 2 even numbers. So 3 choose 3 is 1 times 2 choose 1 is 2. And the number of total subsets of S which contains at least one odd and exactly one even would be 6 plus 6 plus 2. So it's 6 plus 6 plus 2, which is 15. Again, fundamental counting principle says that if you have part A, part B, part C, and you can do part A in R different ways, and part B in T different ways, and part C in S different ways, the number of ways you can do the whole A, B, C is R times T times S. And we used it here to find 2 to the power 5 number of the subsets without any condition. We used it here for the number of subsets which contains 2 but not 4. And we used it here to find number of ways of having at least one odd and exactly one even.